Okay, we're going to look at differentiation of e to the x and ln x. Now I've left on here that this is C3 differentiation, so whenever you're looking for past paper questions, it's C3 papers that you would look at. So y equals e to the power of x, and for all of these we have to find dy by dx. So if y equals e to the x, dy by dx is just e to the x. It's as straightforward as that. When we differentiate e to the 2x, dy by dx is e to the 2x, then we'll have to differentiate the power, so differentiate 2x, you would get 2, so we'd write that as 2 e to the 2x. For the next one, y equals 5, e to the power of 1 over x. To differentiate that, we get 5e to the 1 over x, and then we'll have to differentiate 1 over x. So now if you were doing that, you would bring the x up and it would become x to the power minus 1. So differentiate that, you would get minus x to the power of minus 2 then. And then to tidy it up, I would put the minus in front of the 5 and I'd bring the x to the minus 2 down to be x squared. So it's basic differentiation of e to the x. Basic differentiation then of ln. So ln, y equals ln of x, differentiate that, we get 1 over x. Y equals ln of 3x, differentiate that, we get 1 over 3x, and then we'll have to multiply, we'll have to differentiate the x part. So differentiate 3x, we would get 3. And obviously that, the 3's would cancel and that would give you 1 over x. Y equals ln of x squared plus 1. dy by dx is 1 over x squared plus 1. Multiplied by, we have to differentiate this part here. So differentiate x squared, we get 2x. Differentiate 1, we get 0. So again, tidy it up. We can write it as 2x over x squared plus 1. Okay, the second differential then, y equals e to the 4x, so if we differentiate that to get dy by dx, we get e to the 4x, then we'll have to differentiate the 4x part and we get 4. And then the second differential would be 4e to the 4x, then differentiate the x part and we get times by 4, so that's 16 e to the 4x. Differentiating then y equals ln 3x, so dy by dx is 1 over 3x times differentiate the x part, so times 3, and that's 1 over x. So getting the second differential then, well remember 1 over x, you'd write it as x to the power of minus 1. So when we differentiate that, it's just back to normal differentiation. There's no ln or e to worry about. So it's minus x to the power of minus 2. I would write that minus 1 over x squared. Now the same as with any kind of differentiation, and it doesn't matter with e to x, ln x, we'll be doing trig, we'll be doing all sorts. You have to be able to find turning points or stationary points, and you have to be able to answer questions on tangents and normals. So we'll look at one of each. So find the stationary points of y equals e to the x plus e to the minus x. So we know stationary point, your turning point, we find dy by dx. So differentiate e to the x, we get e to the x. Differentiate e to the minus x, we get e to the minus x times minus 1. For a stationary point, dy by dx has to equal 0. So we have 0 equals e to the x minus e to the minus x. So bring that over. E to the minus x equals e to the x. So that's 1 over e to the x equals e to the x using your rules of indices. Multiply across. You would get e to the x times e to the x, or e to the x squared. So I'm going to take the square root. And then take logs at, well, you could take logs at both sides and get log 1 equals x ln e, which you would know ln e is 1 and ln 1 is just 0. Or you could just say, well, e to the power of x is 1, so it's something, e to the power of something gives us 1, which you know it has to be 0 then. So we've got the 0, the x coordinate, sorry, of the stationary point then, so we need to find the y coordinate. So y equals e to the x, so e to the power 0, plus e to the power of minus x, so e to the power 0. That's going to give us 1 plus 1, which is 2. So our stationary point then is 0, 2. Okay, and then looking at a tangent here, find the equation of the tangent to the curve y equals x plus e to the x at the point 1, 1 plus e. So we know when we're talking about equation of a tangent, we'll have to find dy by dx. So differentiate this, differentiate x, we get 1, differentiate e to the x, you get e to the x. Now our x coordinate of our point is 1, so when x equals 1, dy by dx equals 1 plus e. So that's the gradient of our tangent. And we've got the x value and the y value, so now we use y minus y1 equals m upon x minus x1 to find the equation of the tangent. So y minus 1 plus e equals our gradient 1 plus e upon x minus 1. So multiply out the bracket. We get y minus 1 plus e equals 1 plus e x minus 1 plus e. And you can see if you take this across, they'll just cancel each other out. So y equals 1 plus e x, and that's the equation of our tangent.